Hello and welcome to the channel for chemistry revision. I know these are the exam times and one of the most tension times for all the students because it's the time for term and exams. So what's going to be important for term and exams, guys? Term and exam revision. All right, so let's quickly start the topics for revision today. All right, students, so let's quickly continue the learning objectives for review today and the revision for term and exam. So these are the learning objectives for our review. Why carbon forms so many organic compounds, number one. Number two, what is saturated and unsaturated hydrocarbon and how do we name simple alkanes and cycloalkanes. Number three, what is an addition reaction? And number four, process to separate petroleum. Alright, so the first one is why carbon forms so many organic compounds. So there are four main reasons for this, guys. Number one, carbon has four valencies or bonds. So if you see here, all the gray atoms in the center are carbon and each carbon is bonded to four other sides, three sides with the hydrogen here, 1, 2, 3, and one side with the other carbon. And this gives us a 5-carbon simple compound that's called pentane. Another example is propane. This is the structural formula here of propane. You can see 1, 2, 3, 4 bonds for all the carbon. So this is the first reason, 4 sides a carbon can bond. And that's why many compounds it can form. Different types of arrangements. Number two, it can form straight chains, ring compounds and branch chain compounds. So let's see some examples. This is a straight chain. It's a 7-carbon compound, so heptane. Then this is a ring compound, ring containing compound. Benzene ring is also an example, but this one is a normal aliphatic ring, guys. And we can see it's methyl cyclopentane. It has formed a closed structure like a cyclic. That's why cyclopentane. And the third one is 2-methyl heptane. 1, 2, 3, 4, 5, 6, 7, 8. 3-methyl octane it is. This is the compound which is for a branch chain. There's a misprint in the naming here. It's actually 3-methyl. 1, 2, 3, 4, 5, 6, 7, 8. 3-methyl octane, guys. So these are the reasons, 2 reasons. Then next, number 3, carbon can form different types of bonds, and that's the another reason why it can form many compounds. You can see a carbon compound here. It has carbon-carbon single bond and double bonds. So basically this one is an alkene, and if you see the second one now, that has carbon-carbon triple and a single bond. So this is the one that makes more variety of organic compounds. Also, the fourth reason is it can bond with other atoms such as oxygen, nitrogen and sulfur. Let's take an example of this compound here. So it's like an amide, and you can see this, each dot or point here is a carbon. So its C is bonded to oxygen and this C is bonded to nitrogen. So that's the reason why carbon forms different functional groups and hence many organic compounds, guys. Saturated and unsaturated, that's the second objective. So very simple, saturated hydrocarbons have carbon-carbon single bonds. So if you see this reaction here, we have ethene reacting with hydrogen gas in presence of palladium or nickel catalyst to form ethane. So the very simple understanding is since ethene has double bond, it's unsaturated, and ethane has single bond, it is saturated. Now, unsaturated compounds can also have triple bonds, so alkyne is also unsaturated, guys. How can we test this? So test for unsaturation is simple. We take the reddish brown bromine water and we add the substance we want to test, whether it is unsaturated or saturated. What happens in the result? So if the brown color of bromine water disappears after adding the substance, we confirm that the compound is unsaturated. So unsaturated compounds with double bonds, they remove the brown color. Saturated compounds show no positive test here. No color change happens if it's all single bonds already. Then addition reaction is also an objective. So addition reaction, name also suggests addition, when two compounds combine to form a bigger one, or two group of atoms. So you can see ethene combining with hydrogen here to form ethane. So this is an example of hydrogenation, and hydrogenation is a type of addition reaction. And this is a characteristic property of alkenes, guys. So alkenes give addition reaction always, because they have a possibility of adding substances on a double bond. Double bond can break, it can form single, and on the two valencies new substance can add. Then the process for separating petroleum is the next objective. So this process is called fractional distillation, and the apparatus we use it in industries is called fractionating column. You can see a fractionating column here. The crude oil or petroleum is put here down, and it is heated in a controlled setting, and when the temperatures are maintained at different levels, as we go up in the column, the temperature decreases. So right from 400 at the bottom, it goes up to 18 degrees at the top. So right from 400 to 18 it goes. So what are the different things here? So fractional distillation is a process of separating mixtures that have different uses. Crude oil compounds are separated by heating them to a temperature with smaller fractions of mixtures will vaporize, and they will go up because they are light. And generally the components differ by 25 degrees. So there is a difference in 25 degrees between petroleum gas and petrol, the boiling point. And that's why they are separated here, and it is used to